All right, well, good evening, everybody, and welcome to my talk. Tonight, I'm going to be talking about MTHFR as seen in the iris of the eye. And this is my research, okay? So this has to do with a project that I've been doing for 6 months. And it is continuing, it's ongoing. So I'm gonna share with you what I have learned, and there's a lot more. It's, you know, MTHFR methylation is huge, and so hopefully you will learn something from me from this video. There's a lot of people that were not able to be on tonight live, and so I am recording it so you can watch it again. You can study it if you want to, and pass it on. Pass it on to anybody that you think that'll benefit from this information. You know, it's free. I'm going to put it on the website and you can download it, you can share it. I think the more people that learn about MTHFR and how it can affect the body, the more people it'll help. And I think it's really important. So on that note, I'm going to go ahead and get started here. So my name is Brenda Generali. For those of you that don't know me, I am the president and CEO of Joyful Living Services. Our school is sanctioned by the International Iridology Practitioners Association, which I'm very excited about. I am a comprehensive iridology instructor for levels 1, 2, and 3, and a certified nutritional consultant and a member of the Guild of the Naturopathic Iridologists Association, and a supporting member of the California Naturopathic Association. So my website here is joyfullivingservices.com. And my email is iridology@netzero.net. And there you see my phone number. So those are there in case you want to reach me. If you have a question, concern, if you want to learn more, if you want to be part of the study. I am still looking for people that are interested in being part of our study. So if you want to be a part of it, happy to have you be a part of that. The first thing I need to do here is go through our disclaimer. Joyful Living Services cannot be held liable for any misuse or malpractice of any information taught within this presentation, nor for any injury, suffering, or distress caused by anyone undertaking the techniques discussed. Everyone must accept that they are wholly responsible for their actions relating to the practice of iridology and MTHFR, and must adhere to the relevant laws in their country and state of residence. Everyone is responsible for ensuring that they have appropriate liability insurance for practicing in their country and state of residence. Joyful Living Services cannot be held responsible for any advice given by anyone who has seen this presentation to members of the public. All participants must adhere to their local laws regarding the requirement for registration and/or qualification as an iridologist before suggesting supplements or offering nutritional advice. So this is me, and I have this picture here. This is me in 1988 here. I volunteered at what was called the International Iridology and Health Symposium. It was Dr. Bernard Jensen's 60th year of healing work. And they had the symposium for him from August 27th through September 1st. And here I am. I volunteered to take pictures of people's irises. And so I'm sitting behind one of these Dr. Jensen cameras here at the symposium. And I took so many pictures. I was so lucky to be able to do that. And it made such an impact. I didn't even know Dr. Pesic took this picture of me, and he sent it to me. He says, I took a picture of you. Would you like it? That was, I don't know, 3 or 4 years ago. He sent that to me. I didn't even know. But, you know, iridology has been my love for so long. So my path, let's give you a little bit of information about myself. My path to iridology actually began in 1983 when I had my own personal health issues that began at about the age of 12. So I had a lot of bowel issues at the age of 12, but I didn't understand it then. But as an adult, what happened is I was very stressed and I had a lot of digestive issues and a lot of bowel issues. And luckily, I was seeing somebody that had a friend that was seeing an iridologist in the Bay Area. And this lady had endometriosis, and she was getting good results. So she suggested that I see her iridologist. Well, he wasn't available. So I found another iridologist, Chris Wickert, who is still my iridologist. He's actually up in Washington now. And he, I went to see him. He did analysis and gave me a bunch of herbs, told me what to take. I did everything and it helped. So, I started sending friends to him and they got better. And one day out of the blue, I just called him and I asked him, I said, how do I find out more about this? I was curious. And he said, well, Dr. Jensen is down in Escondido and he teaches. Why don't you call down there and see, maybe you can take a class. And I called down there and it just so happened that they were teaching a class in August and they had room for me. So I went down there. I didn't know if I was going to like it. I went down there and I loved it. I absolutely loved it. So I stayed for the advanced class. I got fully certified by Dr. Bernard Jensen and started receiving referrals the next week from their office. And here I am over 30 years later, still working with iridology. It wasn't my plan. It's not like I took the class because I wanted to get certified to do iridology. It just happened. And it's been something that I've been very interested in all of these years. So my path, that was in 1989 when I became certified by Dr. Jensen. And then my career in iridology, that led me to develop Joyful Living Services and set up goal setting and mission statements and so on. In 2018, I became a member of IPA. Hold on, sorry. In 2018, I became a member of IPA, and I'm also certified as a genomic iridologist by Dr. Michael Salas. He's down in LA, and I'll be talking about him here in a second. So today I see clients all over the world, and my future goals include writing an iridology textbook and becoming an iridology fellow and eventually becoming a naturopath. So this is Dr. Salas here. So why did I choose to study MTHFR? That's a very good question. In 2019, I attended an IPA symposium and Dr. Salas was there. And he presented his research on MTHFR. Well, I had never heard of MTHFR before. I didn't know anything about it. And, one of those things, I'm sure you've had that experience where you'll hear about something and it'll pique your interest and then you want to know more. Well, that's what happened when I was sitting there. It's like he was talking about all these things. And, I thought about it and I thought, you know what, this may be the answer to my health issues. There's certain things in my body that aren't getting better. And I wanted to find out why, and I had yet to find the answer. So I found out that he had held studies on his patients that had brown pigments. And he was trying to determine if there was a connection between brown pigments and this MTHFR mutation. So after his talk, I went into the vendor room and sat down and talked to him, asked him if, I told him I was very interested in it. I'd like to work with him. And he was very open to the whole idea. So I started working with him and went down and interned with him and have decided to hold a 6-month peer review to continue his research. During this time, I found that orange pigments in both blue-eyed people and mixed biliary-eyed people are also connected to the MTHFR gene mutation. So far, all my clients who have had brown or orange pigments who have been tested, and that's the key, those that have been tested, because a lot of people, I suggest that they go get tested and they either can't for some reason or they don't. So I have no idea about them, but the ones that have been tested that have the brown or orange pigments have all tested positive for this MTHFR gene mutation based on their blood tests. And I'm going to show you some of those case studies. So I want to thank Dr. Michael Salas for all his support and training. And it's really been a blessing to me. So what is MTHFR? Well, it's the most talked about gene among health enthusiasts and functional medicine practitioners. It became a very popular topic after large-scale studies linked poor methylation with chronic health problems, such as cardiovascular diseases, which includes blood clots, stroke, embolism, and heart attacks, depression, anxiety, bipolar disorder, schizophrenia, colon cancer, acute leukemia, chronic pain and fatigue, nerve pain, migraines, recurrent miscarriages in women of childbearing age, and pregnancies with neural tube defects, such as spina bifida. So learning about MTHFR is important as it allows you to determine how efficient your body is with the methylation cycle. And by understanding this, you're able to implement lifestyle changes that can help with methylation and increase your quality of life, which is something that we all want, right? We all want to have improved health. MTHFR. So MTHFR stands for Methylene-tetrahydrofolate reductase. And methylene-tetrahydrofolate reductance, or MTHFR, is an enzyme that breaks down the amino acid homocysteine. The MTHFR gene that codes for this enzyme has the potential to mutate, which can either interfere with the enzyme's ability to function normally or completely inactivate it. And that's where it gets a little scary, is when it can be inactivated. So here you see, I've got a picture here. I've got an image here with the two parents, parent one, parent two, and here you are. So it's your mom and your dad, and here you are. And then your significant other, and if you have children. So people inherit, so this would be you here, people inherit one copy of the MTHFR gene from each of their parents. So we have two genes that we have here. There's A1298C and C677T, and you inherit one of each, okay? You inherit one gene from each of your parents. So everyone has two of these genes. And mutations can occur in one or both of these genes. If you have a parent or close relative with an MTHFR gene mutation, this can increase a person's risk of inheriting that same variant. And mutations can affect one, which is called heterozygous, or both, which is homozygous, of these genes. And people who have two parents with mutations have an increased risk of having a homozygous MTHFR mutation. So we are studying both of those genes, the A1298C and the C677T. And what they're saying is that mutations in MTHFR genes occur in approximately 25% of people of Hispanic descent and 10 to 15% of North American Caucasians. Personally, I think it's more than that, but that's kind of what they're saying. So these mutations can lead to high levels of homocysteine in the blood. Okay, so methylation in humans affects the cytosine nucleotide, and it is the process by which a methyl group, which is a carbon atom of 3 hydrogen atoms attached to it, is bound to the cytosine nucleotides. This is when it gets kind of complicated here. Okay. MTHFR is a key player in this process. People with 2 copies of the C677T variant, which is only about 4% of the population, they produce an enzyme whose activity is reduced by about 70%. I mean, that is huge. If you think about that, people with 2 copies of this variant, of the C677T variant, they produce an enzyme whose activity is reduced by about 70%. That's just huge. So the steps to converting folate to MTHF, or methyl-tetrahydrofolate, involves many enzymes, including MTHFR. Now, this is a simplified methylation pathway, and I'm not even going to begin to try to go through all of these pathways with you. I'm going to explain some of it to you, and you can study this if you want. Maybe you've already looked at it, maybe you understand it, and that's great. But I'm going to go ahead and just give you some information here about this. So the methylation cycle starts with homocysteine, okay? One of the molecules affected in this pathway is involved in making DNA. Another one, which is called MTR, or methionine synthase, this converts homocysteine to methionine. Okay, it needs vitamin B12 and 5-MTHF to function. SAMe has a methyl group attached to it, which it can pass to our DNA, causing DNA methylation. The end result of the methylation cycle is methionine, but it also produces other compounds important for antioxidant defense, such as, and you've heard of this, glutathione, and affects folate metabolism. We often hear about ways to turn off or on genes, but not about the biochemical basis of it, which is methylation. Methylation occurs by adding a methyl group, which is one way of turning on or off a gene. In normal cells, methylation ensures proper gene activation and silencing. And DNA methylation causes a crucial modification to the genome that is involved in regulating many cellular processes. These processes include chromosome structure and stability, DNA transcription, and embryonic development. So if the methylation cycle is less efficient, if the activity of MTHFR is reduced, then homocysteine can build up because not enough of it is being converted to methionine. And high homocysteine levels are a big risk factor for many diseases, which is the ones that I already said. So inflammation, heart disease, diabetes, autoimmune, neurological issues, and cancer. Now here we have DNA hypermethylation and DNA hypomethylation. In DNA hypermethylation, a healthy body has a certain amount of methylation, okay? Irregular or over-methylated DNA can change a gene, preventing it from producing what it's meant to. Changes in the placement of methyl groups can cause diseases. So this can cause cancer, lowered immune system function, damaging brain health, lowering energy and exercise, and quickening aging. And it can inactivate and reduce the expression of certain tumor suppressor genes. External and environmental factors, they can also alter methylation. And this process can be altered by everything around us. Now with DNA hypomethylation, too little methylation can also be harmful. Okay, if there's insufficient methylation in the body, it can cause genomic instability and cell transformation. Hypomethylation can be beneficial for cancer short term, okay, but it can also speed up cancer growth. And methylation in cancer has been described as too much, but too little. In cancer, some parts of the DNA are overmethylated and other parts are undermethylated, and that can lead to a complete imbalance of the normal methylation cycle. So hypomethylation can also contribute to inflammation, leading to atherosclerosis and autoimmune diseases such as lupus and multiple sclerosis. And here we have DNA demethylation. So DNA demethylation can also play a role in the formation of tumors. And this happens in early embryos and is essential for stem cells to differentiate into specific cell types. DNA regions are turned off and on, and then they're modified via demethylation, again, for healthy development to take place. Demethylation removes the modification of DNA nucleotides. So I've got a diagram here What is homocysteine? Well, homocysteine is a sulfur-containing amino acid that the body produces from another amino acid called methionine. Foods that are high in methionine include meat, egg whites, and seafood. And homocysteine is usually found in very small amounts in your body, okay? And that's because your body converts it, well, it's supposed to, okay? It's supposed to convert it efficiently into other products with the aid of B vitamins, okay? Higher homocysteine levels can indicate a deficiency of these vitamins. And I think there's a lot of people walking around on the planet that are deficient in these vitamins. Higher homocysteine levels have been linked to heart disease, cognitive dysfunction, and dementia. If you look at this picture here, you can see here that there's a lesion, okay? And so homocysteine injures these arterial walls, and then fatty substances accumulate here, okay? And then you have these circulating immune cells known as monocytes. They rush to the site of the injury, which causes inflammation. Then you have these arterial cells, and they proliferate in an effort to heal the lesion, causing plaque to form on the vessel lining. So, you know, we all know this as hardening of the arteries, cholesterol, right? And accumulation in the arterial walls. So what does homocysteine do? When it interacts with the B vitamins, homocysteine converts to two substances. The first one is methionine, and that is an essential amino acid and antioxidant that synthesizes or creates proteins. Okay, the other one is cysteine, and that is a non-essential amino acid which is synthesized from methionine, and that reduces inflammation. It increases communication between the immune cells, and it increases liver health. So now I've got a chart here to show you. This is genetic polymorphisms and health implications. And we can see here the two genes here, the C677T and the A1298C. And here with the C677T, we can see here some issues. So the thermolabile or temperature sensitive MTHFR enzyme, and there can be decreased with decreased MTHFR enzyme activity and reduced methylfolate, we can get into some problems here. So we have homocystinuria, impaired methylation, reduced SAMe, and reduced glutathione. And this can create increased risk of elevated levels of homocysteine, cardiovascular disease, thrombosis, stroke, neuropathies, and adverse pregnancy outcomes. So neural tubes, stillbirths, and preeclampsia. You're going to see this in one of the case studies along with some pregnancy issues. Okay, and then with the A1298C, this can have impaired production of tetrahydrofolate, okay? And this is required as a cofactor or substrate for nitric oxide synthesis, urea cycle conversion of arginine to nitric oxide in citrulline. It's required for ammonia detoxification and neurotransmitter biosynthesis. Okay, and when there's problems, there can be excess ammonia, increased oxidative stress, reduced levels of this is a word I have a hard time with, monoamines, impaired production of glutathione, and increased production of excitotoxins. And this can be associated with depression, anxiety, insomnia, chronic fatigue, fibromyalgia, multiple chemical sensitivity, autism spectrum disorders, migraines, seizures, dementia, Parkinson's, digestive infections, inflammation, and hypersensitivity. I'm sure, you know, you've heard of all these things, and I'm sure you know people that are having issues with these things, with these health issues. And so with enzyme impairments, so if somebody is homozygous, which means they have double gene error, this can increase the risk for these polymorphisms. Okay, so Dr. Michael Salas, he has created 3 charts, and I want to share these charts with you. I have them up on my wall. I go over them with my clients. I think they are fantastic. And you know, I didn't know anything about these until I started working with him. And just realize that this is methylation research, okay? It doesn't mean that this is cast in stone, but it is research that's being done. And by continuing this research, we are continually looking at the iris and we're finding these, you know, we're finding these markings. So if you look at this chart here, this is showing where there is a brown pigment anywhere in the iris, okay? And if we see it anywhere in the iris, this can be a sign for methylation defects. And for those of you that aren't familiar with iridology, this is the pupil here, okay? And then this is the iris. So on this chart, we have estrogen dominance, H. pylori, neuromuscular disorders, melatonin deficiencies, allergies, depression, cholesterol, and fatty liver. So I'm going to explain a little bit of this to you. So with estrogen dominance, this is related to estrogen-related cancers, fibroids, tumors, and endometriosis. Okay, H. pylori, this is when B12 is not processed. Okay, this can lead to H. pylori infection, and it's very common. H. pylori is very common. There is a study that's in PubMed. You can look it up. Or if you want, I can send it to you. If you want it, just let me know. Send me an email, call me, message me on Facebook, whatever, and I'm happy to send you a copy of the study. Neuromuscular disorders. This is related to ADD, ADHD, autism, and MS. Okay, and so glutathione, that is a major antioxidant. And when methylation doesn't occur correctly, glutathione isn't produced and our nervous system breaks down. SOD, that's superoxide dismutase, and that's an enzyme that helps break down potentially harmful oxygen molecules in the cells. And this might prevent damage to the tissues. So this is being studied right now for ALS. We'll see what happens. Allergies are histamine errors, and that includes inflammation, asthma, autoimmune diseases, and of course allergies. Okay, insomnia. Okay, this is a melatonin deficiency, unless of course somebody has bad habits, you know, and they've just created the insomnia through bad habits. But it is a melatonin deficiency, especially if somebody is waking up at 3 a.m., you know, every morning, the same time every morning they wake up. Okay, cholesterol and fatty liver. Okay, well then we have depression, and then cholesterol and fatty liver. When we see these brown pigments in the what's called the liver reaction field. So for those of you that are studying iridology, you'll understand those terms. When we see these brown pigments in the liver reaction field, these are called topostable. And what that means, or topostable, what that means is that those brown pigments are actually in the liver reaction field. You know, with this, the brown pigments can show up anywhere in the iris. Okay. Now his second chart here, this talks about Aquaporin water channels. And he's labeled the chart AQP research chart. And we have liver health, calcification, peripheral circulation, brain health, sweat glands, and renal vascular disease. So this chart is showing that when there is a corneal arcus, okay, so here we have, there again, for those of you studying iridology, this is called a corneal arcus. We also call it lipemic diathesis. And when we see this in the iris, anywhere, that it can be a sign for methylation defects. Okay, it can be. It doesn't mean that it is. Okay, so just remember this is research. And when we look at the iris, we're looking at genetic predispositions. We are not diagnosing. We cannot diagnose because we're not doctors. But we can see genetic predispositions. And so there is a possibility, okay, that when somebody has this this lipemic diathesis here, this corneal arcus, that it can be a sign for methylation defects. So if you're interested in learning about this, I've put this link down here at the bottom. This is the Aquaporin water channels video, and it's on YouTube, and you can watch it and learn more about this, okay? But these water channels, they're found in the gut, they're found in the cell membranes, the renal tubes, the secretory glands, and red blood cells, okay? So if we look at this chart, liver health is related to heavy metal toxicity, including arsenic, cholesterol, and it's also related to glucogenesis, which has to do with insulin resistance and diabetes, okay? Calcification, this is related to arthritis, cataracts, and bone spurs. The peripheral circulation and brain health, this is related to dementia, Alzheimer's, and Raynaud's. And sweat glands, this is related to dry skin and hyperhidrosis. And hyperhidrosis is when the palms get wet. They get sweaty. Okay, renal vascular disease. These are the water channels of the heart and the kidneys. And there is a sign in iridology when we look at the iris, and those of you that have been studying advanced iridology with me, you'll understand what this means. Or if you've studied advanced iridology with anybody else, you should understand what this means. So when we see a corneal arcus in the iris, along with what's called a shoe lacuna in the kidney reaction field, then it is possible that there can be renal disease or heart disease can develop. Okay, and the third chart here, developed by Michael Salas, is the BRCA 1 and 2 and CHEK 2. And for this one, what we're looking at here is a lymphatic rosary. Some of you know as lymphatic rosary, flocculations, or tophi. And so these are tophi here, these little dots that go around. Most blue-eyed people have these dots, and they go all the way around the iris. Sometimes not all the way around, but a lot of times they go all the way around, and they're in what we call zone 6. Okay, and so when we see that, this can be a sign for methylation defects. Okay, and this error, once again, it's not cast in stone, but this error can be related to fibrosis breasts, which has to do with fibrocystic breast changes, okay? Breast cancer, ovarian cancer, prostate cancer, thyroid cancer, kidney cancer, and colorectal cancer. And people with this lymphatic rosary or flocculations, they can have a hydrogenoid tendency. And what that means is that they can swell. They can swell, as you know, when you can swell in your fingers and your hands, swell in the ankles, so they can have water issues in their body. Okay, so now what I'm going to do is share with you a few case studies that I've been doing, and I have a lot more than this, but you know, I could go on probably for hours in this talk, and so I'm going to just show you a few. And of course, the first one I'm going to show you is me. And so these are my eyes here. And I am 59 years old, and I had the blood test, and I came back compound heterozygous, which means I have one C677T error and one A1298C error. I do have lipemic, this corneal arcus in my iris. I have the lipemic diathesis. It's been there for a long time in both eyes. I have tophi in my eyes here, in my iris. I am a hydrogenoid subtype. I do have issues with water. I am a mixed biliary iris constitution. Okay, so that's an eye that's both blue, has both blue and brown. And you can see there are brown, orange, and yellow pigments in my eyes. My homocysteine levels are high, and this has been a real issue for me. When I was pregnant with my first daughter, I had preeclampsia, really bad preeclampsia. And when I delivered her, my blood pressure was 200/110. They were really afraid that they were scared that I was going to have a stroke. Since that time, now I had no symptoms before, okay, nothing, no symptoms before. My blood pressure was always fine. Everything was quote unquote fine until, until I went through, I had to go through infertility treatments, and then, and I had preeclampsia, and that's when all this showed up. So I was diagnosed with metabolic syndrome, and I go to the doctor, and the doctor says, you have metabolic syndrome. And I looked it up. It's like, well, why? Why? That's what I want to know. Why do I have metabolic syndrome? What is the cause? And this is why when Michael Salas gave his talk, he piqued my interest, because I've been trying to figure out, how to get rid of metabolic syndrome, and nothing has been working. And then when he talked about methylation, it's like, oh, maybe that will work. Okay, so high blood pressure, high cholesterol, high triglycerides, pre-diabetic. My dad had a stroke 3 years ago. His mom, she died of colon cancer. My maternal grandmother died of a brain aneurysm and had dementia. And my mom has 2 autoimmune diseases. So you can see where this makes sense, right? Because the C677T, this is related to cardio errors, and the A1298C is linked to autoimmune errors. And so I've got both things that I'm dealing with here. I'm dealing with cardio, and I'm dealing with autoimmune. Now, remember at the very beginning of my talk, I just mentioned how I got involved in iridology. I was very, very stressed, extremely stressed. And I had all kinds of digestive issues. So I had really bad IBS and stress to the point to where I was breaking out in hives on my body. I couldn't lay flat on the bed because I was in so much pain. I couldn't eat out anymore because every time I ate out, my abdomen would just swell. And I was addicted to laxatives because I couldn't go to the bathroom. And so I was in this alternating, IBS cycle. I was really miserable. And so thank goodness for iridology. Thank goodness, I went to the doctor, they told me to take Rolaids, and then I took Rolaids, and because my stomach was a mess, I took Rolaids, and then I would swell. And, so luckily I found Chris, and he helped me, and, my life has changed because of iridology. I am such a lucky person because of that. So here's my blood test. In 2018, I had the MTHFR blood test with a positive result for 1 copy of 677T and 1 copy of A1298C variant. And my homocysteine in May of 2021 was 14.2. So not that much higher, but still too high. It shouldn't be that high. It shouldn't be that high at all. And here's some other information here. Even with a good diet that I've had, I was on paleo and I was on all my herbs. I've done multiple detoxes, multiple cleanses. I've done colon cleanses, I've done colonics, I've done kalimas, I've done gallbladder and liver flushes. You ask, I've done it. I've done everything that I could think of. Being in the alternative field for 30 years, I've done so many things. And yet still, my cholesterol, my triglycerides, my LDL, VLDL, all of these were out of balance. Everything was out of balance. And so once I talked to Michael and I started learning about methylation, then I started learning about a few things. And look what happened. So I went into, instead of paleo, which I love paleo, I went into a modified keto. Modified meaning I don't use any dairy, no dairy, and everything, I eat chicken and turkey. And so it's low fat. I don't do butter and things like that. I take methylzyme, which I'll talk to you about it in a few minutes, but that's what helps me methylate. I also use red yeast rice, CoQ10, omega-3s, berberine, and pancreazyme. And once I started working with the methylation, this is the lowest my cholesterol's been in 10 years, 10 years. And triglycerides still a little elevated, but this was in January of 2021. So still a little elevated, but I'll tell you right now, when I gave birth to my first my daughter, my triglycerides were over 1,000 and my cholesterol was over 500. My body just went crazy when I was pregnant with her. And so with my son, they knew what to look for and they watched me very carefully. And when my platelets started going down and my blood pressure started going up, they induced me. And so I didn't have such a severe reaction with my body. But, you know, diet and herbs and methylation and vitamins work. They work. So anybody that says they don't work, I'm sorry, it's true that they do work. Okay, this is a 57-year-old female. She is a client of mine and I've known her for years. She recently was diagnosed with Hashimoto's. So I asked her to have the MTHFR blood test and she did. And she came back homozygous for the C677T. And that means that she has a double gene mutation. So she has 2 here of the C677T. You'll notice that she has brown, orange, rust, and yellow pigments in her irises. When she came to me, she was having multiple miscarriages. And I was working at a fair in San Jose at the time. And she came to me just because she was curious. And I guess what I told her intrigued her. And she made an appointment. And she was on some kind of a medication. I don't remember exactly what it was, but I worked with her to help her. And she got pregnant and she maintained her pregnancy. I worked with her through her whole pregnancy. I work with her kids. She's got 3 kids and they're all in college. So they're not children anymore, but they're all in college now. And I work with all of them. I worked with her. I followed her through all 3 of her pregnancies while she was pregnant. And her eldest son is actually trying to get into the Olympics. He just tried out for the Olympics to swim and he just barely missed it. So we're hoping on the next winter, the next swim, the next Olympics, he'll make it in. So she was recently diagnosed with Hashimoto's. Both her mother and her father were diagnosed with Hashimoto's. She has high cholesterol, chronic fatigue, and her father died of a stroke. I'll show you, here is her blood test here, and you can see homozygous for the C677T. Okay, here is another, this is one of my clients now. She's a 58-year-old female. She came back heterozygous for A1298C, which is a single gene mutation. So she only has 1. She has a mixed biliary constitution. You can see she has brown, orange, yellow, and black pigments. Here's the pigments in her eyes. Okay, so she's got all these different pigments in here, orange, yellow, brown, and so on, black. She's a hairdresser. So she's been around many, many chemicals for many, many years. And she has allergies. And the last time she came in, she told me that she's starting to have pain in her hands. She thinks she's starting to get arthritis. So that's when I asked her to go, actually I asked her before, but, I asked her again to go get checked for MTHFR and she did, and she came back positive. She's got tophi in both zones 3 here. This is zone 3 in the iris. For those of you that study iridology, this is right outside the collarette in the humeral zone and also in zone 6. And she's also a hydrogenoid subtype. Here's her blood test. And she came back positive for the A1298C variant. And then also I ran a cytoscan on her to see what her detox stressors would be. She came back, look at this, she came back very high with heavy metals, fungi and molds, anger, so the emotion anger, and her lymph nodes. She came back high on all of those. She's out of range on all those, even the lung a little bit. But I found it interesting that she came back so high in heavy metals and fungus and molds. So here is a 60-year-old female. She came back heterozygous for A1298C, a single gene mutation. And you'll see here that she's got tophi out here in zone 6. You can see them on in both irises. And she's also developing, it looks like, a brown pigment right here. So she has a blue lymphatic iris constitution. She's a current client of mine. She was diagnosed with multiple myeloma, which is a blood cancer. And when she came, she was already working on multiple programs. She'd gone on several detoxification protocols like Hildegard and also Hippocrates. And then she also was on a very heavy enzyme program. And so she was already seeing improvements with her blood tests. So that was, that was really great. She's not doing any other treatments. But it was interesting to find out that her father passed away from multiple myeloma. Her grandfather had type 2 diabetes, and also she has tophi in zones 3 and 6, and she's also a hydrogenoid subtype. It's interesting. It's not until you start really looking at a lot of different people that you're able to start making some of these, some of these connections. Here's her blood test. She came back positive with 1 copy of the A1298C. And I ran a cytoscan on her also. She came back very high for immune system stressors of adenoids, tonsils, large intestine, liver, lymphatic system, and glyphosates, antibiotics, and bone marrow. I found that interesting. And also same with the emotion of anger. And for those of you that don't know what glyphosates are, that's an herbicide. It's applied to the leaves of plants to kill both broadleaf plants and grasses. And the sodium salt form of glyphosate is used to regulate plant growth and ripen specific crops. So in talking to her, all she eats is organic foods. She's very, very careful about what she eats. Yet this is still in her system. This is still in her system. So it's amazing how we can absorb these chemicals out of our environment. It's pretty scary, actually, if you think about it. Here's a 42-year-old female. She is homozygous for A1298C, which means she has a double gene mutation. Okay, she has a blue lymphatic iris constitution. She has yellow and orange pigments in her eyes. She was also diagnosed with Hashimoto's. She has gluten sensitivity. Her grandmother had cancer of the liver and lung, and her grandfather and aunt both have type 2 diabetes. Her sister has depression and is bipolar, and her appendix was removed in 2018. And here is her blood test. So positive for 2 copies of the A1298C mutation. Okay, this is an 11-year-old boy, and he came back compound heterozygous for C677T and A1298C. And he's got a brown pigment right here that's right next to what we call a lacuna here. So he has a mixed biliary iris constitution, and he's got yellow, orange, and brown in his irises as well. So he's 11 years old, and he's suffering chronic migraine headaches, gluten sensitivity, hives. His great-grandmother had cancer of the lung and liver, and his great-grandfather and aunt had type 2 diabetes, and his aunt has depression and is bipolar. And so we can see these pigments in his eyes as well. Here's his blood test. He came back positive here for the A1298C and positive here for the C677T. And here is another lady. She's 34 years old. She came back homozygous for the C677T, a double gene mutation. Her eyes are amazing because she's got all these colors. She's a mixed biliary, and you can see the blue here, and then you can see the orange pigments. You can see the brown pigments. You can see yellow in here on both eyes. You can see yellow, you can see orange, and you can see, I think there's a brown pigment in here as well. And I put her eyes up, and she also here's her blood test. She came back positive for homozygous for the C677T. Here is a 32-year-old male. He came back heterozygous for C677T, which is a single gene mutation. He has a blue lymphatic constitution, and he's got the tophi all around. And he has brown, yellow, and orange pigments in his eyes. You can see the orange here. He's got yellow, and he's got brown. Okay, and he's got it in this side eye as well, brown and orange here, and he's got yellow. Okay, he was diagnosed with Hashimoto's. He has insomnia, anxiety, headaches, asthma as a child, and he's intolerant to heat. He's intolerant to heat. And here's his blood test. He came back heterozygous for the C677T mutation. So this is a little chart that talks about nutrition and the role of nutrition. And, you can go through this on your time, but, very important to make sure that your nutrition is good, that you've got your B2, your B3, your 6, your 12, folate, choline, serine, glutathione, your C, your copper, your magnesium, and your selenium, and your zinc. Okay, because nutrition is so important, and there's so many people that don't have a good diet, and they don't think about these things. So nutrition is very, very important. So what can you do to help your body methylate? Well, one of the things is to cut out folic acid. Okay, cut out folic acid. If you're taking supplements that contain folic acid, you might want to stop taking them. First of all, find out if you're MTHFR positive. That's the first thing, having that blood test. I do send people to doctors to have the blood test, or to different labs. I use Ulta Labs. There are many labs, Quest, there's many other labs that can do the test to let us know if you're MTHF positive. And so if you are, it's good to avoid folic acid and supplement, with your Bs, increase your greens, avoid toxins. There's so many toxins in laundry detergents and cleaning products and herbicides and pesticides. Detox your body and fix your gut. If you've got candida, got to get rid of candida because that inhibits methylation. Okay, so I've got some protocols to show you. I'm going to go through this really quick because I'm almost out of time. And so let me just show you some of these things that we use for methylation. Okay, the number one is Methylzyme, and this helps with, this is nanoliposome technology, and this helps with all kinds of issues here. I'll just go through this really quick. Metabolic syndrome, this is the one that I take, but it helps with all kinds of methylation issues. And if you want to learn more about any of these protocols, you can ask me, or I have the links on all these pages, and you can go back and look at the links. So we also have CIRC, that's something else that we work with, especially for leaky gut, thyroid, autoimmune, and hypoglycemia, that we work with that, and thyroid especially. This is important, mastic gum. Mastic gum kills H. pylori, and so for people that suffer with H. pylori, mastic gum is really important. And this is a study that's on PubMed, so you can go in and read that study if you're interested. And that is a link that will tell you more about CIRC. It's currently on back order, but should be available again soon. We have glutathione liposome. And liposome is important because it's absorbed real easily. So you can see here, it's good, it helps with asthma and COPD and so on, viral inactivation and things like that. And chronic fatigue, immune regulation, head injuries, and methylation. And there is the link for that one. And then also liposomal vitamin C. And there's also a study here for this. This is good for hypermethylation and connective tissue, heavy metal detoxing, and pathogens, and free radicals, and histamine regulation. And here is a paper that talks about how vitamin C helps with hypermethylation. So you can look that up if you're interested in researching. And there is the link for that. I also put in this methyl combo, and that comes up sometimes when I run the Zyto scan, and that has methylated B vitamins and methyl B12 and methylfolate. So those types, you know, these kinds of things, they help reduce tiredness and fatigue, provides folate, and very important, and supports the nervous and immune systems. And there is a link for that. Okay, I've got a couple others here that I put in here to show you. So the liquid methyl B12 complete promotes energy, contributes to overall central nervous system function, and supports the immune system. And there is the link for that as well. TRS, I work with a lot of people with advanced TRS. This is a zeolite, and there's a lot of different companies out there. So zeolites, you know, they work at the cellular level. They attract and trap and remove heavy metals, toxins, and contaminants. And, you know, they detox over 80,000 toxins, safe for all ages, even pregnant women and nursing moms. So, you know, when we detox with herbs, we tell, you know, pregnant women and nursing moms not to detox because we don't want to, you know, detox them at that time. But the nice thing about zeolites is we can do that without harming everybody. And this is the link for that if you want to learn more information. So, you know, I'm always interested in information. This is ASEA, and I've been involved with ASEA for over 8 years. And ASEA contains redox signaling molecules, and that helps with that cellular messaging between the cells. It helps to improve the messaging between the cells of the body and the immune system. And this helps to increase your own glutathione and SOD. So that's really important. And that is the link for that explains more about ASEA and how that works. So I'm going to summarize at this point and tell you that all of this is presumption. We haven't really proven a thing, right? We're looking at eyes. We're trying to connect these pigments with, you know, with the possibility that there could be methylation errors. And we're looking at blood tests to also make that connection. But we haven't proven a thing. And think of MTHFR as a genetic predisposition, because that's what it is. It's a genetic predisposition. So what's next? Well, we're going to keep studying. I mean, I'm very interested in this. I'm going to keep studying because I think that this is so important to help so many people. And we are looking for other people besides myself. You know, I did this peer-reviewed study for Michael, but we're looking for other people to do peer-reviewed studies. So if you're in iridology and you're interested in doing peer-reviewed studies, you know, talk to me about it, and we'll figure out how you can do that. And we're looking for participants. So are you interested? You know, if you're interested, if you have pigments in your eyes, or even if you don't have pigments in your eyes, but you're interested in learning if you have MTHFR mutations, or you're interested in MTHFR, you can be part of our study. And I mean, I'm going to just keep going with the study. So I think it's, like I said, I think it's so important. So at this point, I just want to say thank you. You know, thank you for spending your time with me. There is my contact information again. You know, if you can contact me and go on the website, you can contact me by email. You can call me up. I'm on Facebook, all over the place on Facebook. And I have that iridology group. And if you're interested in learning iridology, I'm an instructor. So I do teach levels 1, 2, and 3 for IPA. And classes are available at all the time, and you're welcome to become a part of that. So at this point, I'm going to stop the share. And I see more people have joined us. So that is really exciting. So I'm going to go ahead and see if at this point, if anybody has any questions. And then the question is if I can answer the questions that you have. So does anybody have any questions? I guess my first question to you is, did you learn anything from that? Was that helpful? Did you learn anything about MTHFR and methylation? And was that useful to you? Justin, did you want to say something?
Oh, I mean, it was a lot. It was a lot of information and a lot of words that would have to be looked up, but I enjoyed it.
Yes, there's a lot of big words, a
Yeah.
lot of information. Yes, and that's, I mean, you know, that is just the tip. That's just the tip, you know, of the iceberg. And, you know, I actually tried to make this as simple as possible, you know, because I'm not a scientist, and, you know, I figured a lot of people that'd be watching this would not be scientists. So I actually made this as simple as possible. So if you want to get into heavy duty research on MTHFR and methylation, you can.
So my curiosity is actually going towards less complex levels of this. Are you into the human genetic code and the mapping of the genetic code? Have you learned about that, or did you just land on this one particular gene and dive into it?
Yeah, I'm learning about these two genes, the C677T and the A1298C. Yeah.
Okay.
That's where my focus has been.
Okay. Thank you.
You're welcome. So anybody else have any comments, anything you want to add, any questions, anything? Thank you, Terry. All right, well, if nobody else does, then I'm going to end this webinar. So hopefully, you know, if you have questions and you want to contact me separately, I'm available and happy to talk to any of you. And, you know, if you are having issues, or you know anybody that's having any of these health issues, maybe this gives you a little bit of a connection. Like for me, see, this really has answered some questions for me, and you can see from my blood test that it's really helped me. And so please, I will put this on Facebook, and I will be emailing out the recording to everybody, so everybody will receive it. Please share it with anybody you think that it will benefit, your friends, your family, clients, colleagues, whoever, anybody you think might be interested, just share it. And I'm happy if you share the information. Okay. All right. I hope everybody has a good evening, and I will say good night.
Thank you, Brenda.
Welcome.
Thank you.
Night, everyone.